Hi, Mr. Baker. This is Rafa here, and I'm from the group of Joe, me, and Benil. And today I will be explaining to you the determination of copper in the bullet casings lab. And so hopefully you're enjoying your turkey break right now and eating this over some nice KFC or some other bird assortment or species. Okay, so going into this lab, we've got some Beer's law data here that we know that the absorbance equals the molar absorptivity times path length times concentration. And we know if we place the wavelength on the x-axis and the absorbance on the y-axis, we would get this curvy line right here. And so we want the top of this line to be the greatest absorbance, and because that will show the wavelength that we need to use if we go down into our x-axis and what we need to put on our colorimeter to then calibrate that over to the blank cuvette so that we can get some conclusive data for our lab. So using this data as well, we can plot concentration on our x-axis, which is our molarity, and our absorbance, which does not have units, and that gives us a linear relationship. And so with linear relationships, like right here, that create lines with slopes and y-intercepts, so what we can do here is we can then set a proportion. So what you use for this lab is we used 0.40 molarity right here, or molars, of the stock solution, which is 10 milliliters. And so we set 0.40 over 10 equals some concentration over the 8 milliliters of stock solution. So as we create these dilutions, the dilutions have to be diluted by distilled water. And so the nitric acid would be our stock solution for this lab. And so we have 10, 8, 6, 4, and 2 stock solution as you go down from your standard to your dilutions 1 through 4. And then 0, 2, 4, 6, and 8 volumes of distilled water used as well. So now let's jump right into here and zoom up to 200%. Sorry, I'm blind, I guess. Okay. So let's go right here. So the markings on our bullet casing. So we chose a copper bullet that had the AUSA J45 Auto head stamp on it with the ring in the middle with an indentation at the center. And so as you can see here, AUSA J45 Auto, AUSA J45 Auto as well. So let's jump back out here. And this is the bullet that we would use for the rest of our lab. And so now you told us in class that one time that we had to create a stroke problem in order to figure out how many milliliters of stock solution that we needed of the nitric acid. So we ended up needing 22.5 milliliters. And so we surmised that we needed about 24.5 milliliters, as the lab told us that we needed about 2 milliliters more so that we could completely cover that bullet casing and dissolve it all so that we could have a good unknown concentration to use within our lab. And so now this is where you come in, Mr. Baker, and hopefully this program of Screencastify will bear with me. Now I know all the struggles that you teachers have with this stuff. There's your hand right there. So as you can see, you just putting the nitric acid in over our copper bullet casing. Oh my goodness, there is a red maroon gas coming off, and that is our nitrogen dioxide coming off of the copper nitrate salt there that's in the bottom. And so you got some bubbles forming, gas forming right there, and so also color change, so that is indicative of a chemical reaction. So if we just keep on going throughout this video, we're all good there. It just keeps on reacting until it stops. Now, sorry, let me exit this main screen. Oh my goodness. Let's see. Escape. Let's get out of that and jump right back in. So now we had to prepare our dilutions. So we put some stock solution all the way up to 50 milliliters within our burette, and then we filled each with 10, 8, 6, 4, and 2 milliliters of stock solution. Then you said that we had to put some distilled water in there as well. So then we put 0, 2, 4, 6, and 8 milliliters of distilled water, and then we capped all of those pipettes, and then we ended up shaking them in order to properly dilute the solution that we had of the stock solution and the distilled water. And here we have our little outcast, our unknown, the ugly duckling right here. And so we would get that later when Joe sacrifices his hand and gets us our beaker back from the experiment and the fume hood. And then we ended up putting that in the unknown concentration. The test tube. So moving on, so we had to prepare a blank. So specifically within the lab, it says that we had to prepare a blank by filling an empty cuvette 3/4 full with water, and we tried to fill that with 3/4 the best. As you can see, it's not the best angle with the picture right there, but it's pretty good. Then we sealed the cuvette with a lid and made sure there was no fingerprints. All cuvettes had to be wiped clean. We handled the cuvettes only with the top edge of the rib sides. All solutions should have been free of bubbles, and positioned the cuvette with the clear side facing us. And then we plugged in our Lab Pro into our computer, which is this gray block right here. And we plugged that in as well to the colorimeter so that we could record some data for this lab, because we needed to create a little line and plug in our unknown concentration so we could figure out or plug in the absorbance so we could figure out the unknown concentration of the copper within our bullet casing. So we placed the blank in the cuvette slot and closed the lid, which is right there. And we calibrated it over at the greatest wavelength because we saw in the beginning of the lab that we were using a blue wavelength, and the complementary color of blue, I'm pretty sure, is orange. So we want some higher nanometers there. So we pressed the buttons and we pressed the cal button, and when the LED light stopped flashing, the calibration was complete. We went to Logger Pro, and then we started that calibration as our baseline for our data. So we calibrated the colorimeter, and then we started with our S solution right here. We go back up here, bear with me real quick. Our S solution, we put that in the cuvette, and then we calibrate, or we did not calibrate again, because if you calibrate again, it would reset the baseline, which we did do first off, which is our first mistake. Human error happens in labs, and we did not make that again, thank goodness. And so then what we did was we clicked Logger Pro, and we ended up logging all of our data. So we repeated steps for the bullets at different concentrations to identify the materials. At first, what we went to in class that first time, we did mess up because we clicked another data set table. So we had to scratch that and go back. And so now here we have the mass of the bullet. So that's what we recorded almost the first thing that we did in this lab. So it's 5.780 grams. So this is a little foreshadowing because we have to get the percent of copper over the, or the amount of copper in grams over the amount of grams of the bullet to get the percentage of copper that is in our bullet casing, so we can figure out the manufacturer. So we've got the concentration right here of our standard and our dilutions 1 through 4 and our unknown concentration of copper. So this is the absorbance right here. So we've got 0.284, 0.186, 0.373, 0.550, 0.688, 0.8514 for respectively increasing concentrations. And that just shows that linear relationship again, because as one side increases, the other side increases as well. Unless there's an indirect relationship when they would be increasing and decreasing, which is not the case for this lab. But it is the case for transmittance. But we did not get into that much for this lab. So then we graphed a line regression equation. So looking right here, though, we've got an absorbance of 0.284, which falls in between these values right here, which means that our molarity of our unknown concentration of our copper should be about between 0.160 molarity or molars and 0.080 molars as well. So I'm guessing about 0.13, 0.12 maybe. It's about smack dab in the middle there. So graph a line regression equation. We did that with our A value or our slope being 2.057 and our B value or y-intercept being 0.03598. Then we clean up our station and we determined the absorbance value of the unknown copper, and that's just shown right here in this glary image. Oh my goodness, I'm so sorry for that. So it's 0.284 and there's no units there. Then we've just got the data table again. This is just for the rubric, just to show that we have this. This is the graph that we had from Logger Pro. Set up. Thank you so much for showing us that application. It made it a lot easier to graph our data instead of using our calculators. Then we've got this as well. This is just our data table, but in Logger Pro form. Now we've got some post-lab questions. So as I said, this is our A values that we have here. And so we have our RMSE as well that we will need to put down as well. And so this is our R value right here, which is 0.9985, and the closer it is to 1, the better it is. And so also, as we keep on going, so the unknown concentration of our solution based on absorbance. So I had Joe plug in 0.284 for our Y value, which is the absorbance because it's in the Y axis. And then we ended up getting a concentration of 0.12, which is pretty close to what I thought, 0.12057 molars to be exact. So then Joe ended up doing the equation work for this, which was really nice. It's coming back from quarantine, really came in clutch here. So we've got some molars right here times 500 milliliters over 1,000 milliliters because we ended up using 500 milliliters, and we notated that as well within the lab. And then he multiplied by the molar mass to get 3.3 grams of copper used. And as I said before when I prefaced, it's got to be 3.83 grams over the grams of the bullet to get the amount or percentage of the copper that we had to use. And so that was 66.3% copper. So then for 4, so our percent by mass of copper kind of looked like it was between the manufacturers of Lapua and Lapua. Lapua at 75% and Lapua at 62% copper. But we got 66.3, which is almost like the average between the two manufacturers. So we figured it was somewhere in between Lapua, between the Muntz metal, and we figured it must have been that one. But this is not agreed completely with our markings, as our markings were not indicative of any of the manufacturers given. So research online that I conducted for a while showed that the bullet should belong to an ACP, or an automatic Colt pistol, which is not what we used, which is not what the head stamp measured or showed. So this did not really go along or corroborate our data. And so the AUSA J45 markings were not present in the rest of the table on the lab as well. So in here, we've got some data as given below for the absorbance of copper sulfate versus its concentration, so what mass of copper could be produced. So we've got our handy-dandy balanced equation. We've got some single replacement going on here, looks like, because our cation of our zinc ends up replacing our cation of copper and pairs up with the polyatomic anion of sulfate. So going down into this, we've got y equals 2.057x plus, that's just our line regression equation that we got from our graph. And so getting this molarity for copper sulfate, what we do then is a simple dilution problem where we just do molarity times moles. And that would get us our moles of copper sulfate. Let's see, good right there. And then we've got we plug in our 0.158 moles of copper sulfate. And we do a little bit of molar equationing skills right here, because we look back at our balanced equation and get the mole to mole ratio. And then we got 0.158 moles copper, and we multiply that by the molar mass to get the grams of copper used into the post lab. So that was our mass of copper. So right now you're actually on the lab report video, so you're making a cameo there. So you'll see that eventually posted in the link when you look at the lab report as well. So this is the rubric. And I'd just like to thank you so much, Mr. Baker, for this opportunity for me to present this to you. I love enjoying the tedious amounts of recording this video over Screencastify, because my computer kept on crashing and there was a bunch of pop-ups in previous videos. It's embarrassing, but I really like this lab and I like the group that I worked with. And I appreciate your time, the gift of your time, and hopefully you have a great turkey break with your family, Mr. Baker. Have a great weekend or break. See you later, or whenever I see you.